question. If you can remember the power rule, it says that the integral of x to the power of n is going to be equals to x to the power of n plus 1 over n plus 1 plus c. So I am going to do another example before I introduce another subtopic under integration, in case you didn't understand the last time. So I'm going to repeat again. So the integral of 4 x to the power of 3 plus 3x to the power of 2 dx is going to be equals to, remember we take the integration of each. So we said that integration is the reverse of differentiation. So we're going to do each of them. So we're going to start with, so we're going to have, this will be equals to, I'm going to have 4x to the power of, so it's going to be 3 plus 1 because we said it's n plus 1. So this will be 3 plus 1, then over 3 plus 1. And then we say plus, and then we're going to have 3x to the power of 2 plus 1, 2 plus 1 over 2 plus 1, and then plus c. So don't forget we add plus c. And then after this, we are going to have 4 x to the power of 3 plus 1 is 4. So we're going to have 4, and then over 4 because 3 plus 1 is 4. And then plus, and then we have 3x to the power of 2 plus 1 is 3. So this is 3, and then 2 plus 1 is also 3. And then it's going to be plus c. And then now this is equals to, so I'm going to rewrite this step so that when I cancel, you can understand. So this will be x to the power of 4 over 4, then plus 3 to the power, so 3x to the power of 3 over 3, and then plus c. So we are going to cancel. Okay, I want to see. So we are going to cancel the 4 and the 4, and also the 3 and the 3. So I'm going to use another color. So these are going to cancel. So this 4 cancels that one, then this 3 cancels that. And then I am left with, my final answer is going to be x to the power of 4, and then plus x to the power of 3, and then this is plus c. All right. So that's how we integrate. So that's our answer. Then now let's move on to B. So B, we have, okay, I'm sorry. So B, we have x, then x to the power of 7. So remember, we need to have x to the power of, when we integrate, we should have x to the power of n, x to the power of something. It must be a base and an exponent form. So because they look like this, we're going to start by solving this first before we integrate. So our answer is going to be, before we integrate, so we are going to say, sorry. So we are going to say the integral. So now we're going to distribute the x to the power of 7. What do I mean by distribute? I am going to do this. So let me do it on the side so that you understand. So what I mean is that we have x to the power of 7, then bracket 1 plus 1 over x to the power of 7. So we are distributing. So we're multiplying x to the power of 7 with everything inside the brackets. So we are going to have x to the power of 7 times 1 is going to be x to the power of 7. Then plus x to the power of 7 times 1 over x to the power of 7 is going to be x to the power of 7 over x to the power of 7. So a number divided by itself is 1. So when these two cancel, they give you 1. When we cancel, we don't get 0, but we get 1. Please understand that. When we cancel, we don't get 0, we get 1. Okay. Let me close and open it again. Please note that part 2, integration. I wrote differentiation, sorry. It's integration part 2. Okay. Right, so we are going to have 1. So these two, so x to the power of 7 over x to the power of 7, these, they cancel. So when they cancel, please, they don't give you 0, they give you 1, because canceling is the same as dividing. So this is, I just wanted to do this on the side so that you understand where I got my answer. So I am going to have x to the power of 7, just to avoid having a lot of steps. I did that step on the side so that you understand. So this will be, I can use red here so that we understand. Let me just use red so that you see what changed. Okay, so this is x to the power of 7, then plus 1. So how did I get it? I did it on the side here. Okay, all right. And then now we integrate each and every one of them, remember? So this will be x to the power of 7 plus 1. X to the power of 7 plus 1 over 7 plus 1. If you remember, 7 plus 1 over 7 plus 1. What am I doing? I'm following this power rule of integration. Okay, and then we say plus, that's 1. So with this one, it's going to be 1, then x to the power of 0 plus. If you remember from the last lesson, so this is 0 plus 1, then over 0 plus 1. If you remember from the last lesson, please go back to the first lesson of integration, the one before this one, okay? And then this will be just plus c. Never ever forget the plus c. So we are going to have x to the power of 7 plus 1 is 8, then over 8. 7 plus 1 is 8, okay? And then we have plus, and then this is 1, just here. Then x to the power of 0 plus 1 is 0 plus 1 is 1. Okay, so we are going to have x to the power of 1, then over 1. And then don't forget the plus c. This is plus c. And then this will be equals to, so I'm going to rewrite this because, yeah, that's my answer anyway. So this will be x to the power of 8 over 8, then plus 1 over 1 is just 1. So this is just x to the power of 1, then plus c. Okay, so that's how we integrate. You can't integrate if you don't have your function in this form. It must be like x to the power of something. You can integrate it looking like this. And then now we move on to, what is that? Sorry. Now we move on to C. Okay, so now we have C. Again, we need to change this. So remember, just going to write it on the side. So please remember that the square root of x, remember that the square root of x is the same as x to the power of 1 over 2. So that's what I'm going to apply here. So please remember that. I'm going to apply that here before I start integrating. So it means that here I am going to have the integral of, so this will change and become 3x plus 4, then to the power of 1 over 2 inside the bracket, then dx. So now if you can see, this looks like a function of a function. So now it means that we must use the reverse of chain rule in integration. So we are going to do that one of let 3x plus 4 equals u. And then now we start solving. Okay, so we are going to have, we're going to start first by letting u equals. So I'm just going to do that here. I'm going to say let my u equals to 3x plus 4 because this looks like a function of a function. And then after this, I have to differentiate. If you remember very well from our last lesson, we differentiate. So it means that now I'm going to take the derivative of this. So the derivative of u, so du over dx, the derivative of this is going to give me what? 3. How did I get the 3? I'm going to do it on the side. So the derivative of 3x plus 4 is going to be equals to 3x to the power of 1 minus 1, if you remember, and then plus 0 because the derivative of 4 is 0. So this will be 3x to the power of 0, then x to the power of 0 is 3. So that's how we differentiate. I'm just doing this so that you remember. Okay. So now I said, if you remember, I said you need to swap this. So we are going to swap. So when we swap, we are going to have du over 3. So 3 is going to take a place of dx, if you remember very well what I said the last time. I'm swapping because I'm avoiding having a lot of steps, because I want dx to be alone, and then du on the other side. Okay, so this is what I did. So what did I do here? I swapped. Here, I swapped. So I wrote it here. I even wrote it the last time. I hope you understand. So when we swap, it's allowed mathematically, is correct. So when we swap this, 3 takes the place of dx, dx takes the place of 3. And this is just with the fraction. Please don't do this everywhere. This applies only with the fraction. Okay, so now it means that my dx is going to be du over. So let me write it here. So it means that therefore it means that dx is equals to du over 3. And then now we are going to now start integrating. So now it means that when we integrate, so the integral, okay, just enter. Okay. So the integral, so it means that the integral of 3x plus 4 to the power of 1 over 2 dx is going to be equals to. So now we're going to substitute. Sorry, I just want to use a black so that when I use the blue, understand, okay? So now we're going to integrate the integral of 3x plus 4 to the power of 1 over 2 dx is equals to the integral. We said 3x plus 4 is u, so I'm going to use a red pen so that you understand. So this will be u to the power of 1 over 2. And then now, if we can check, I have my dx. We said dx must be what? We said dx must be du over 3. We are just substituting here. Here we substitute. So this is du over 3. What did I do here? I substituted. I said wherever I see, so I substituted. We can check. I used this. Wherever I saw dx, I put du over 3. And then I also substituted this one. Wherever I saw u, I put 3x plus 4. Where? Here. Okay, now I can start solving. So before I solve, I am going to move this 3. So this 3 is the same as 1 over 3, okay? So du over 3 is the same as 1 over 3 du, okay? So I'm going to take this 3, so I'm going to do this. Please do this all the time. So it's 1 over 3, then the integral of u to the power of 1 over 2, then du. So now we can derive. This is the derivative of u with respect to u. So now we derive. So this is going to be, when we derive, this will be times du to the power of 1 plus half is 3 over 2. Remember we say plus 1. So it's 3 over 2, then over 3 over 2. And then this is plus c. Don't forget, how did I get this? Okay. I said a u to the power of 1 over 2 plus 1 over 1 over 2 plus 1. It gives me u to the power of 3 over 2 over 3 over 2. Okay. And then that's what I did, all right? Okay. So that's how I got my answer. And then now this will be, if you divide 1 over 3 over 2, is going to be 2 over 3. Okay. That's what I did. Okay, let me just do this. And then after this will be equals to, write it here. This is equals to, when you divide here, 1 over 3 over 2 is going to give you 2 over 3. Please refer to the last lesson. You'll understand how I got this. But when you say 1 divided by 3 over 2, you're going to get 2 over 3. It's the reciprocal. Okay, with the calculator, you say 1 over a fraction. What is a fraction? 3 over 2. Then it's going to give you 2 over 3. Do you understand that? So it means that here I am going to have 1 over 3 times 3 over 2. And then this is, sorry, let me just make a space. Okay. This is just u to the power of 3 over 2. Okay, let me just do this because I don't have a space. Let me rewrite it at the bottom. As I said, 1 over 3 over 2 is going to give you, or 1 divided by 3 over 2 is going to give you 2 over 3. Please use a calculator, you'll understand. 1 over 3, then this is going to change. Remember I said, I wrote it here. It's 2 over 3 u to the power of this. So this is 3, 2 over 3, ne? What am I saying? 2 over 2, sorry. It's 2 over 3, then u to the power of 3 over 2. And then this is just plus c, and then we are going to have 1 over 3 times 2 over 3 is going to give you 2 over 9. Then this is u to the power of 3 over 2, then plus c, and then now we substitute our u. We said our u, it's 4x plus 3, so this will be 2 over 9 bracket. I am changing back my u. So let me confirm if I make a mistake. I'm sorry. Go up. Okay, yeah, it's 3x. We said u is 3x plus 4, so I'm going to change it back into 3x plus 4. This will be 3x plus 4. So I'm just changing back the u, nothing else. And then to the power of 3 over 2, then plus c. So that's our final answer. So this is a function of a function. Same as the chain rule. So we're just reversing the chain rule. Okay. And then now we're going to number D. So with number D, we are going to have also this one is a function of function. You'll see it's cx plus 3, 6x plus 3 to the power, everything to the power of 4. So it means that we're also going to do that thing, the chain rule, reverse of the chain rule. Okay, so we are going to say let u equals 6x plus 3. Okay, and then now we do the du dx. Okay, let me find another color. I like that color, I can see it. Okay. Okay, let me try green. Okay, so now I am deriving u. I'm gonna say the derivative of u over dx is going to be equals to 6. Again, how did I get the derivative? Please remember that when we derive, I'm just going to write it on the side again because I don't want it to disturb me. Okay, so the derivative of 6x plus 3 is going to be equal, with respect to x, is going to be 6, then x to the power of 1 minus 1, then plus 0, if you remember. The derivative, I'm just doing this so that you understand, but honestly, there's no need for me to do this, just in case someone was asking or someone had it wondered where we got the 6. Okay, so when you take the derivative of this, your answer will be 6. Okay, and then after we derive, remember I said we swap, so we are going to swap. So when we swap, we're going to have a du over, I'm just going to use a different color. Okay, we're going to have over 6. Maybe this one is not visible. Let me look for another color. So I'm just changing. Okay, just okay. I don't like red because it feels like we're doing the same thing. Okay, so this will be over 6 and then equals to a dx. What did I do? I swapped. Swapped 6 with dx. So therefore it means that my dx is equals to du over 6. So wherever I see dx, I'm going to put du over 6. And then this one, wherever I see u, I'm going to put, wherever I see is, I'm going to do that. Okay. Now let's integrate. So now we have found we have two most important things, which is the x and our u. Okay. So now we are going to integrate. Oh, sorry. We're going to integrate. Just gonna move down. Okay. Yeah. Okay, let me create a space here. Okay. So we are going to integrate. So when we integrate, remember the reason I said we swap, it's because of the long method of solving the x here. So I'm just avoiding long steps. So you always do this when you get to this step, please. It's gonna assist you. And then now we integrate. So we're going to say the integral. So remember we have the integral of 5 over 6x plus 3, everything to the power of 4 with respect to x. So this will be, is equals to, so we substitute. Now we're going to substitute. It's going to be 5, then over. We said our 6x plus 3 is u, so that's what I'm going to do. So I'm just going to say u, then it will be to the power of 4. I just substituted, and then I haven't started deriving first. And then dx, we said dx must be du over, so that's what I'm going to do. I am substituting, so my dx must be what? Du over 6. Please note that I substituted. What did I do? I subsed. Okay, so I substituted u. Okay, let me not say u, let me say, yeah, u, or 6x plus 6x plus 3 with u. And then I substituted a dx with a du over 6. I'm just doing this so that you understand. I hope this helps. That's what happened here. That's what I did here. Okay. And now we continue. Now we can integrate. So before we integrate, you must make sure that we move the 6 to the other side and also the 5 so that you are left with only a u. So remember that, okay, so let's see. So I am going to have 5 over 6. 5 is at the top, 6 at the bottom. Then I have my integral sign. And then I have 1 over u. So you can take the u to the top first, okay? Then I'm left with the u this side. So what did I do? You can just see, I took this 5 over 6, I put it this side. Then now I continue with my work. Okay, I hope that makes sense. And then now, before I integrate, I must take this u to the top. Remember, it must be in the form of x to the power of n. So this is 5 over 6. Then now what do? I'm just going to say this is going to be u to the power of negative 4. So u will be to the power of negative 4. Then now I can integrate. Okay. This du. Okay. Now we can integrate. So this is just 5 over 6. Then bracket. When we integrate u to the power of negative 4, we're going to have u to the power of negative 4 plus 1. Don't forget, we add 1. Integration, we add 1. Differentiation, we minus 1. This is the denominator also. It's going to be over negative 1, negative 4 plus 1, sorry. Okay. And then don't forget the plus c because I integrated. Okay, now we can solve. Okay, let me just enter. Okay, now we can solve. So when we solve, we are going to have, this is 5 over 6 multiplied by u to the power of minus 4 plus 1 with the calculator is going to give you a negative 3, and then over a negative 3. Okay, then plus c. And then you remember I said u, I'm going to rewrite this one again so that it makes sense. Please note that so that you don't ask me what happened. Note that the u to the power of negative 3 over negative 3 can be written as 1 over negative 3 and then u to the power of negative 3. Please note that so that you understand what's happening here. So I'm just going to multiply these two. So I'm going to end up having 5 over negative 18. If I'm not mistaken, let me confirm. So I will have 5 over 6 times 1 over negative 3. Okay, yeah. So it is going to give me negative 18. Okay, and then don't forget this is u to the power of negative 3, then plus c. And then we don't want our u to be negative, so this will be 5 over negative 18, and then 1 over u to the power of positive 4. This is the reason why. So this u now, this will be positive. How am I saying positive 4? Positive 3. Okay. Don't forget our plus c. And then we are just going to have, oh, sorry. Okay. All right. Okay. I want to enter. Okay. Okay. So I will just have 5, because 1 times 5 is, remember it's a multiplication here. Don't forget. So this is just going to say negative 18. Okay, it's just negative 18. And then our u is 6x plus, let's see, 6x plus 3. I hope I did everything correct. 6x plus 3. Okay. So I will just have, because remember u, it's 6x plus 3, 6x plus 3, then to the power of 3. Don't forget your c, then plus c. Even if you change the c here, it's still fine. There's nothing wrong with that. It's still fine. Then we just end up putting it down the denominator. Because remember we said that x to the power of negative n, just a reminder, is the same as 1 over x to the power of positive n. Just to remind you that. Okay. All right. Then now we move on to e. So with e, okay, so with e, we have the integral of this, okay? So again, I'm just going to change this first. So you can see this also a composite function. So we have So that means it will be u. So firstly, let's start by saying this is x to the power of 4. And then this will change and become x to the power of 5 minus 4 to the power of 1 over 2 dx. Okay. So now we let our u is going to be x to the power of 5 minus 4. And then now we do the du dx. Okay, I've done that, so I'm not going to repeat what I did before. So it's du over dx is equals to 5x to the power of 4, because remember it's going to be 5 minus 1. Yeah, so it's going to be 5 times, yes, don't forget it's x to the power of n is going to be n x to the power of n minus 1. Okay, please remember that. Yes, okay. All right, so now please listen. On this one, when we swap, we're only going to swap with the 5. Please, we're going to leave the x on the right-hand side. The only thing that we swap is 5. Every time, you only swap the number, nothing else. Please remember that. We swap the number, nothing else. So we swap. So when we swap, we are going to have, so this will be du over, then we swap, you're going to have the 5. And then this side now, you will have what? So this side you are going to have, this is equals to x to the power of 4, please. X to the power of 4, the only thing that's going to move this side, it's the x. Please note that the only thing I swapped is 5 and dx. So I swapped here, please. I only swapped 5 and dx. Please note that. Okay. So now we move. There's a reason why. The reason why we don't swap there because of this x to the power of 4. You're gonna see how we move around with this one. Okay. So now we can integrate. Because I've been doing these other steps, I'm just gonna move. I'm not gonna repeat some steps now because I've done them. Okay. So now we integrate. So the integral of x to the power of 4, then x to the power of 5 minus 4, then to the power of 1 over 2 dx. This will be equals to, now we are substituting. Okay. Let's substitute one at a time. So I am going to substitute first. This will be the integral. Okay, I'm going to start with u first so that you can see it. So this will be u to the power of 1 over 2. Okay. And then what's left? If you can check here, what's going to be left? I am going to be left with x to the power of 4 and dx. Okay. So now let's see. I'm just going to write it here. So I have x to the power of 4 and dx. I have x to the power of 4 and dx. So I'm going to substitute them so that you can see what's happening. So I have my u to the power of, okay, let me still use red so that you can see. So you can substitute at the same time. The reason why I'm doing this one is because it's a little bit different from the previous one because of the x to the power of 4. It's not really a big deal. Then I'm going to substitute this x to the power of 4 dx. We said it must be what? Du over 5. Okay, it was green. Du over 5. We can check it. It must be du over 5. Okay, then now you know the drill. You take the 5 to that side, it's going to be 1 over 5. Don't forget. So this will be 1 over 5. Then the integral. So we have u to the power of 1 over 2, then du. Okay, now we can integrate. So this is just going to be 1 over 5. Then this will be u to the power of 1 over, don't forget, 1 over 2 plus 1 is 3 over 2. Don't forget, please. It's plus 1 again. It's going to be 3 over 2, then over 3 over 2. Please don't forget. Okay. I just want to use brackets here. Please don't forget it's 1 over 5. And then this is 3 over 2, we got it from 1 over 2 plus 1. It gives you 3 over 2. Please don't forget. Okay. Let me confirm it also. 1 plus 1 over 2. It gives you 3 over 2. And then I said that this is going to be 2 over 3. I think I did it on the previous lesson. If you don't know how I got it, please go back here to understand how I'm going to get this is going to change to 2 over 3. It's here. I did it here. I did it here, please. You can go back and check again if you do not understand. Okay. Just need a space here. Okay. All right. Okay, let's enter again because it's about to finish anyway. Okay. So now we are going to have, and then this side I will have what? The 2 over 3. And then this will be u to the power of 3 over 2. Why did we forget the plus c? Okay. This is a plus c. I forgot the plus c. Then I just multiply. So this is 2 over 5. 15. 3 times 5, it's 15. And this is u. Okay, let me change the u here. Okay, let me just write it before you ask me I got it. Only, there's no need to write so many steps. I'm just doing it so that you can understand. Okay, so this will be, this one is not going to the bottom. Why? Because the exponent is not negative, because the 3 over 2 is not negative. Please note the difference. This one, it became 1 at the bottom because our exponent was a negative. This one, our exponent is a positive. So this will be 6x plus 3. Am I saying the correct one? Okay, it's 6x plus 3. No, it's x to the power of 5 minus 4, sorry. X to the power of 5 minus 4. X to the power of 5 minus 4. Now I'm writing the previous one, sorry. And then this will be to the power of 3 over 2. Honestly, 3 over 2. And then this will be plus c. Okay. All right, so that's how we write our answer. And then now we move on to, okay, so if that doesn't happen most often, okay, doesn't happen most often. And then now we are going to move on to the indefinite integral. I hope I wrote the correct spelling. The definite integral, they're saying that a definite integral is a way to calculate. Oh, sorry, I need to charge my laptop. Okay, let me charge, sorry. Okay, sorry. They're saying that a definite integral is a way to calculate the total accumulation of a quantity, most commonly the area under the curve between two specific limits. So you can go to your study guide and see what they mean. The graphs are there to show you the 2 points we're talking about, the area we're talking about that is under the graph, and those 2 points that they use. Okay. And then it says here, in economics, a definite integral is used to measure total quantities when you are given a rate marginal value or a curve. Okay. We'll see that as we move on. And then the formula for the area that they're talking about, is the integral from a to b of a function, dx. And then now you take those 2 points, you substitute them into your f. So it's going to be f of b minus the f of a. You're going to see what I mean when I do an example. Sorry. Okay. So now we have an example. It says evaluate each of the following integral. Okay. All right. I'll evaluate each of the following. So the first thing you need to do, obviously, you need to find your integral. Okay, so we're going to find the integration of this function that we have here. So the integral of this first, so that's what you start with. You find the integral of x plus 2. Okay, so we find the integral. So the integral of this is going to be with respect to the x. We've done this, you know it's going to be x plus, so this is x squared. So remember it's 1 plus 1 over 1 plus 1. Okay, let me just do it for now. This will be 1 plus 1 over 1 plus 1 because there's always a 1 here, if you remember. And then this is plus. And then this one of 2 is going to be 2. Then x to the power of 0 plus 1. If there's no x, obviously it's going to be 0 plus 1 over 0 plus 1. Then it's plus c. Okay. And then our answer is going to be x squared. That's how they get the answer, x squared over 2, then plus 2x to the power of 1, and then this is plus c. Okay. And then now when we want the, when we do the integral of this function from the 2 point from 0 to, sorry, not 0, 1 to 3, we are going to have now, so this will be this one. Okay, let me just use the colors. So when we evaluate, so we're going to have, okay, this is 3. Of x plus 2, and then dx. So this will be the integration of x plus 2 we got. So we have x squared over 2 plus 2x. Please note that we do not consider the c because the c's are going to cancel. All right. So I don't consider the c because at the end of the day, those c's are going to cancel. So just follow my lead. Sorry. So this will be from, you can just write it like this. It's up to you how you write it. So this is from 1 to 3. Okay. Then it means that my answer is going to be, remember we said that the integral, so it's supposed to be f at b minus f at a. Okay. F at b means that I'm going to substitute. So this will be it's going to be wherever I see x, I put 3. I start with 3 because b represents 3. So this will be 3 to the power of, wherever I see x, I put 3 first, over 2, then plus 2 times, then I put 3. Okay. And then, okay, I'll just use a square bracket. And then after this, I minus. Okay, so it'll be minus that minus. And then now again, wherever I see x, now I put 1. That's what we do. 1 to the power of 2. Then plus 2. And then 1. Okay. Okay. So when we do this and use our calculator, we are going to have, okay, so I'm going to say 30 to the power of 2, sorry. 3 squared over 2, then plus 2, sorry. So I'm going to have 21. So here the answer will be 21. I'm going to have 21. Sorry, okay, 21. This is 21 over 2. then minus this one of 1, put 1 there, and to be 5 over 2. And then when you minus the 2, so this will be, my answer is going to be 8. So that's your final answer. That's the value. When they say evaluate, it means we're going to have the answer at the end. So that's the answer. So this is how we go about it. So let's try it again. Okay, let me just use brackets. Let's see again. Okay, so that's what we do. The C's are going to cancel. So please ignore the C in this case. Even if you put the C here, it was going to cancel with this one, this side, because of this minus. Okay. You can try to put the C, you'll see they're going to cancel. Now we go to this one. I'm going to do the same thing that I did. Now we have this function. Remember, we integrate each and every one of them. So I'm going to start by integrating. So I'm going to say the integral of x squared minus 2x plus 3. I'm not going to do the long method of integrating. We have to integrate. Ne? I hope I didn't say differentiate. Integrate. So when we integrate this, we are going to have x to the power of, remember it's 2 plus 1, it's 3 over 3. Then minus, then it's 2x. Then 1 plus 1 is 2 over 2. Okay. We'll also do this with the red. It's 3 over 3. Okay. And then we have plus. This will be 3x. Remember, this is 3x to the power of 1 over 1. There's no need though to write over 1. I'm just doing it. And then this is plus c. Okay, we're going to ignore the c when we do the, when we evaluate, when we substitute those 2 points. Okay, 5 and 1. Okay, so now we are fine with the integral. So now we can do it again. So the integral from 1 to 5. Okay. So of what? X squared minus 2x plus 3 with respect to dx is going to be equals to, I'm going to use the square bracket. Oh no, I'm going to say this. So which is x to the power of 3 over 3. And then minus 2x to the power of 2 over 2. And then plus 3x. Okay. This is with this interval 1 and 5. Now we substitute. So remember, x and 2 they're going to cancel. There's no need to write this. So this will be, I'm going to use the square brackets. So it means that it's going to be 5 to the power of, wherever I see x, I put 5 first. You always start with the value, bigger value, that one. Okay, in case you're wondering. So this will be 5, then minus. There's no need to write the 2 though. I could have cancelled the 2 again. Okay, let me just put it here. Someone's gonna ask, why didn't you cancel? We can cancel, you can cancel. Honestly, it's not gonna make any difference. Wherever I see x, I'm going to put 5 in this one. 5, 5. And then you can also check your notes to see what happens to the c. But as I said, they cancel. And then minus, now we substitute the 1. So this is to the power of 3 over 3. Then minus, sorry, plus minus. There's no need to, you can divide these twos and they cancel each other. Okay, because I forgot to cancel them, I'm just moving with them. Okay, so this is 1, 1, 1. Okay, now we can use our calculator. So for this one, I am going to have Okay, I'm using a calculator. So I have 5. Okay. 5 to the power of 3 over 3, and then minus. Oh, sorry, just using a calculator. Please bear with me. Yeah, with me. Okay, got 95 over 3. I got 95 over 3. 95 over 3. Then minus. If I made a mistake, you can check your study guide. I took this question from the study guide, so we must get the same answer. Okay, this one is 87 over 3. Okay, then when we use our calculator, we get 88 over 3, which is the same as approximately equals to the decimal number. So it's 29.33. So it's 3333. So I wrote 33. Okay. All right. And then now and remember remember I said that our assessment is a multiple choice. So obviously you have to check your answer on the multiple choice, the one that is closer to 29.33. And then now we go to C. So with C, we do the same thing. We're going to have, this is a co-function also. So we're going to first integrate. That's not a co-function, sorry. We're going to integrate first. So I'm going to integrate the 40. Find the integral of this before I use it. Okay. All right. Okay. And then you will notice that we have a co-function here. Okay, this one's going to be a bit longer. I'm using the reverse of chain rule. Okay, let me see if that's what they used here. Because it feels like we're using that. Yes, exactly. So we're going to use the reverse of, because of this, a co-function, as I said, because of this. Okay. So we're going to integrate this first. So remember we say u. We let u equals to, don't forget, we let u equals to 2x minus e. And then after that, we find the derivative. Okay, let me see which color can I use. So I've done this before, so I can't, yeah. So we've done this, you know by now. So the derivative of this, e is a constant, ne? So the derivative of this is going to be 0 or 0. Yeah. So this will be du over the x. It's going to give us 2. Then we swap. When we swap, we're going to have a du over 2 is equals to the x. Please don't forget. And then after we swap now we're going to integrate. So remember we're integrating before. We can substitute the 0 and 2. Okay. So I am going to have now the integral of 40 e to the power of 2x minus e dx. So this will be, we take the 40 this side, and then we are going to have, okay, the integral of e to the power of 2x minus e is u, if you remember. This is u, okay. And then we have our dx, we said is going to be what? Du over 2. I've done this. I'm not going to do it the longest way. Okay. Then now I'm just going to have 40. The integral of, okay, 40, then I take this to the side over 2. Okay, this 2 comes from here. Let me write it with green. Okay. Before I integrate, so this is e to the power of u. Do you remember we want this two together? 40 divided by this is 20. Then I have the integral of this, it stays the same. It's just e to the power of u. Then plus c. From where? Remember we did this last time. We said that the integral of u just stays the same. Integral of e to the power of u is just e to the power of u. Please don't forget that. Okay. And then now it means our answer is going to be, our integral is just going to be 20. Then this is e to the power of our u. We said it's 2x minus e. E is a constant, né? So this is just going to be 2x minus e. And you'll see that on your calculator, you should have e. Yes, we do have e. All right, this is just plus c. So now because we're evaluating, we're going to ignore the c if, like I said, because they end up canceling each other. So I don't like including them in this business. Okay. So therefore, now we can do our business. We're done integrating. So our business is with the integral from 0 to 2. Let me use a red pen. From 0 to 2. Of what? Of what is it? 40 e to the power of 2x minus e dx. So this will be, I'm going to put my answer in bracket. This 20, yeah, then I put that 2x minus e, and then we put the grade law from 0 to 2. Okay, now we can substitute and get our value. This is, okay, okay, just need a space. All right, so this is going to be, I'm going to use the square bracket, so it's 20 e to the power of 2. Then we said, oh, we start with the bigger one, so x is 2. And then minus e. There is a value of e on your, there is a e is a constant, please. It's then your calculator. If you press alpha, you'll see the e there at the bottom. Okay. It's a constant, so please use it. And then this is minus, and then this is 20 e to the power of 2, and this is 0. So any number to the power of 0 is 1 anyway. Okay, 0 minus e, oh, it's a negative. Okay, it's minus e. You can use a calculator there. Let me see if I'll be able to get the value. So it's 20 and e, sorry, alpha, and then exponent. Okay, I did get a value actually. All right, so this one I got 72,05 Okay, I'm just gonna end with 3, like 3 decimal places, 3 numbers after the comma because I'm not done. Okay, and then this one I will have, okay, okay, this one I am going to have, sorry, it's alpha. You press alpha, then you'll see the e there. It's in pink. Okay, so I got 1,376. Obviously, like honestly, it's no, you can write 3 numbers after the comma, round off. I think we can all round off. So this is 798. I get it to 76, so it's gonna be 98. And then my final answer will be, I'm going to get 70,736, which is approximately close to 70,736. 0.74. You round off to the nearest. So if the number after the third, this one is bigger than 5, you add 1 to that 3, so it becomes 4. Okay. Let's see if I did the right thing. Okay. Okay. Our answer is not the same. Why? So I put the... Oh, I made a mistake here. Sorry about that. Yeah. Oh gosh, I distributed the 20. I was not supposed to write the 20 here. Please excuse that. The 20 is supposed to be outside. Oh gosh. The 20 is supposed to be outside. Sorry about that. Okay. It's supposed to be here. I'm not supposed to put the 20 is supposed to be outside, not here. I distributed the 20. I was wrong. So if you have that, it's supposed to be here. And then, oh my word. Sorry about that. My apologies. The 20 is supposed to be outside. I distributed the 20. Why? I don't know also. Okay. All right. Please forgive me. Yeah, this is taking too much time because I am doing it the longest way. So this will be, yeah, okay. I'm sorry about that. Okay. So it's e to the power of, and then minus e to the power of, okay, I'm sorry about that. I made a mistake. So this is 20 bracket. Inside the bracket, I am going to have, sorry about that. I am going to have 3. I hope I didn't make a mistake. 3,5, 3, 6, 8, 3, 6. Okay, let me just say another 6. There's no need to write the longest number. I'm just doing it. Okay. Why am I getting the wrong number? It's e to the power of. What am I getting? But I keep getting the wrong. I'm not getting this answer. Just don't know why. Unless if we didn't use the same value. My apologies. Okay. I used, it is the same. It's like, why am I having the different answer? Is it because I did it at the same time? Because I punched in 4 minus 3. Okay, let me say start again. Oh my word. I'm so sorry, guys. I think I am trying to get the same answer as the one they got here. Okay, let me just do it. So this will be 1 minus e. Okay, I think they made a mistake here. Yeah. Oh, I'm not wrong, sorry. My answer is not, I'm not in the same question. Forgive me. Mine is 2x minus 3, ne? Minus e, not minus 3. Yeah, we're not going to get the same answer. Sorry about that. I'm not doing the same question. So this is e to the power of 0 minus e. I'm right. I'm not wrong. Sorry about that, guys. So my answer is going to be 70. I'm not wrong, comma. 7367. Approximately can say it's 70, comma 74. Yo, I didn't see that. Mine is different. It's to the power of, it's e. It's 2x minus e. Yeah, mine is 2x minus e, not minus 3. Yeah. All right, sorry about that. So let's do the last one. And then that will be it. So this one, the same thing happens. We need to find the integration of this. So this will be the integration of x squared plus 1 over x, sorry, x squared plus 1 over x before I do anything, dx. Okay, so this will be equals to, remember we said that the integration of 1 over x dx is equals to ln x. Please don't forget that, ln x plus c. Just to remind you. So I have, here I am going to have the integration of this will be x to the power of 3 over 3, because it's 2 plus 1, don't forget. And then plus ln x. Your calculator also has ln. And then we say plus c. Now we have the integration, now we can evaluate. All right. So the evaluation of this is going to be, so the integral from 0, 2 to 1 of this x squared plus 1 over x dx is equals to x to the power of 3 over 3 plus ln x. I said ignore the c. Remember I said the c's are going to cancel. There's no need to write them. So this is going to be 0, 2, then 1. Okay. Then now let's do things. So I'm going to use square bracket. The square bracket of this one, okay, there's nothing here, is going to be over 3, and then plus ln. Then I put, wherever I see x, remember I am putting 0, 1 first, the bigger one. Between 0, 2 and 1, 1 is the bigger one, okay? And then minus, and then I say 0, 2 to the power of 3 over 3, then plus ln 0, 2, okay? So now I'm substituting the 0, 2. So this is 0, 2, 0, 2. Okay. Now let's see what we get. Okay. Sorry, guys. This is 4. I remembered when I was doing that one that I made a mistake here. This is 4 minus me. Okay. And then this will be, use a calculator. So we are going to have your ln. When you get ln, you press, oh, ln is just there. You'll see it on your one of the buttons. Okay. It's just there. Okay, so this is 1 over 3. Ln 1 is 0, I guess, because I got 1 over 3. And this is minus. Let's see what I get. Just let's see what I get. Okay, I get a negative. I don't know. Oh no, it's triple of 3. Sorry. Over 3. Yeah, I still get a negative. I hope I didn't do anything wrong. Okay. I get a negative here. So this is negative 1,60677. And then my answer is going to be my answer is going to be 1,94010, and then approximately I can just round it off, so 1,94, because the number after 4 is less than 5. Okay, so I hope I did it correctly. The derivative of with ln x. Okay, yeah. So that's it. Okay, let me stop the recording. So if I made any mistakes, please feel free to ask when we meet, but I hope I made it easy. The video is long because I was just trying to make, I was just trying to make sure that we all understand. I know it's a bit longer for others, but I apologize in advance. I'm just trying to check here. Don't forget that mine was to the power of e on this number C. I'm just confirming the answer again because I felt like I made a mistake before. All right, yeah, so it's fine. Okay, I will stop the recording now. Thank you very much.